Okay, this type of sample is known as the stratified random sample, and I'm going to let you know it's my personal favorite. Not that I really it matters that that's the case. It just is. A stratified random sample breaks things up into strata. And what's important about the strata is, if you'll notice here, I broke this up into 5 strata. All right. So we'll take a look at the very first strata. The very first strata is made out of boxes of 1 and 2. So that these are very small. The next one was made out of boxes of 4, 3, 4, and I think 5. The next one was a little bit larger, and the last one was made out of the biggest ones. So we have strata that are divided into groups. And we could think of this as dividing it into, and are broken into groups based on a common characteristic. And we could think of breaking this into groups of like freshmen, sophomore, juniors, or seniors, all right? So basically, anytime you break it onto a common characteristic, you have a stratified sample. So with a stratified sample, it's like, well, we forced you into a group and you can only be in one group. And that's to say with freshmen, sophomores, juniors, and seniors, it's like, well, you can't be a freshman and a sophomore. You can't be, you have to be in one group or the other. So we're going to put you in one group. And then from each of the groups, from each of the strata, we are going to randomly make a random selection, all right? So basically I have to number everyone in the strata from 1 to 20, which is what was done here. I have 5 groups and I'm gonna go to each group and select from 1 to 20. When I did that, from group 1, I chose element 3. And element 3 was a 1. Then I went to group 2 and I chose element 4. Slide this up. And element 4 was 1, 2, 3, 4. Then from group 3, I chose element 5. And element 5 was 1, 2, 3, 4, 5, 6, 7, 8. From the 4th strata, I chose element 20, which was 1, 2, 3, 4, 5, which is 10. 1, 2, 3, 4, 5, and 10. And then from the last group, strata 5, I randomly selected element 6. Now I use the random number generator on the calculator to do this. And I had 1, 2, 3, 4, 5, and this is 5 times 3 is 15. I took the average and got 7.6. Now it happened that this one was closer. It just happened that way. But the fact of the matter is, with this group, I am basically going to every single strata and so making a random selection within the strata. Now, when I begin, every single individual has an equal chance of being selected. But once again, not every single group is possible. If I do a simple random sample, it's possible that I would get all 5 of mine from strata 1. But that if I did a simple random sample with everyone in a hat, it's possible that it would only be from these, I only choose from one strata by accident. But when I do a stratified sample, I'm assured to have strata 1 represented, strata 2 represented, strata 3 represented, strata 4 represented, and strata 5, which means not every combination is possible. Consider this. If I put everybody's name in a hat at Reagan High School, it might not be likely, but it's possible that when I drew that all I draw were freshmen. So it's conceivable that a simple random sample, every combination is possible. It's possible to have all freshmen in a group, or all sophomores, or all seniors. But with a stratified sample, I'm assured of having every group represented. Now, the reason I like stratified samples is because you know something about the population. And because I knew something about the population and I knew that there were strata, I could divide it on strata. Male and female could be the way I divide it. I could sit there and go, you know what? I believe the hormone medication is going to affect females differently than males. So I might want to stratify based on gender. I may want to stratify based on age, as in young people may react to the vaccine different than elderly, etc. I may want to stratify based on how in shape or out of shape an individual is. So there's a lot of things that I might want to stratify on or break into groups. Now, one of the biggest issues that my students have are the difference between stratified and cluster. Remember, in a cluster, we say that each group looks like the population. Let's see if I can pull it up. Each group looks like the population. Each group has some small and some large. In a strata, you had only small in one group, and then only only large in the other group. So it's broken down by size, whereas each cluster looks kind of like the population. Another way to think of it is we could have groups. Let's just say our population, we had this giant population, and our population was made out of A, B, C, D, and F. In other words, grades. Okay, so we had a giant population that's what they look like, student grades, A, B, C, D, and F. So I'm going to go ahead and make some rows. And I know this is going to take a moment, so bear with me. And remember, I said that a cluster looks, that'll be enough. I said a cluster looks like the population. So if I circle this way, circling them this way, this looks like the population. These would be clusters, because every single one of them looks like the population. They look like A, B, C, D, and F. They contain all the elements of the population. So A, B, C, D, and F would be the clusters. However, if I were to come back, instead of going that way, and so then I would randomly select, I'd go, okay, I'm going to select one of the clusters. I have 4 clusters. I randomly select one. I survey everything in it. That way, when I survey everything in it, I'm assured of having an A, a B, a C, a D, and an F, regardless of whether I chose cluster 1, 2, 3, or 4. Randomly select, and I'll get one of those and it represents everything. If I did a stratified sample, I'd be circling this way. And notice I have all my A students, all my B students, all my C students, all my D students, and all my F students. These would be strata. And I would randomly select from A, that would choose me an A. I'd randomly select from B, that would give me a B. I randomly select from C, that would give me a C. I randomly select from D, and that would give me a D, and I randomly select from F. So in a strata, you randomly select within each strata. So stratified, randomly select within each strata. Cluster, you randomly select a cluster and perform a census. So they're kind of exact opposites. With a cluster, it looks like the population. You randomly select the cluster and you survey everybody. With a stratified, you go to every single strata and you randomly select within that strata. Okay, both are pretty good methods. Cluster is difficult for humans, but very useful in other things like in medicine or something that has large batches. Stratified, very useful if you know something about the population that has differences. We know that men are different than the women in this particular study. We know that high school students are different than elementary students. We believe that sophomores are different than juniors, are different than seniors, are different than freshmen. Okay. All right. Thank you for that.